Hello, welcome to the JEE MAIN 2024 Session 1 Detailed Solution Series. We'll be dealing with the physics paper from Jan 31st evening shift. We'll start with the first question. The question says, a light string passing over a smooth light fixed pulley connects two blocks of masses m1 and m2. If the acceleration of the system is g/8, then the ratio of masses is. Now, this is basically an Atwood machine, and the acceleration of the system A will be equal to the net force divided by the total mass. The net force will be m2g minus m1g, that is m2 minus m1g. And that divided by the total mass would be m1 plus m2. The question says that the acceleration is g/8, which means g/8 is equal to m2 minus m1g divided by m1 plus m2. And you cancel off g from both sides and then cross multiply. You will have m1 plus m2 is equal to 8 times m2 minus m1. On expansion, you have m1 plus m2 is equal to 8 m2 minus 8 m1. You rearrange it and you get 9 m1 is equal to 7 m2, which means m2 divided by m1 will be equal to 9/7. The ratio of masses will be option D, 9/7. Right? It's a very simple, straightforward question. You must be knowing this formula directly. Now, the next question says, a small spherical ball of radius small r falling through a viscous medium of negligible density has terminal velocity v. Another ball of the same mass but of radius 2r falling through the same viscous medium will have terminal velocity equal to. Now, the question says that the medium has negligible density, and in that case, we can neglect the effect of buoyant force. Now, in that case, the two forces acting on the ball, the falling ball, would be one, its weight, that is mg, and two, the viscous drag acting on it against the direction of motion, that will be 6 pi eta rv, 6 pi eta rv. Now, when the ball hits terminal velocity, that is, it is moving with a constant velocity, the forces acting on it should balance each other and cancel out, leaving the net force 0, which means these two forces should be equal. 6 pi eta rv should be equal to mg, at v velocity being the terminal velocity. Alright, now, when m is kept constant, according to the problem, if the second sphere is made so that m is still a constant, and g is anyways a constant, and so is 6 pi and eta, we can say that vt would be proportional to 1/r. And this is purely because the mass is kept constant even in the second case. Now, if Vt is proportional to 1/r, when the radius is doubled, the terminal velocity will be halved. So I can say that Vt dash will be equal to Vt by 2 when the radius gets doubled, which means the correct answer would be option D, V by 2. The terminal velocity in the second case will be half of the terminal velocity in the first case. All right, now we will move on to the next question. The question says, force between 2 point charges q1 and q2 placed in vacuum at r cm apart is F. The force between them when placed in a medium having dielectric constant k is equal to 5 and r/5 centimeters apart will be. Now, the question says F, the force between the 2 point charges in the first case will be equal to k q1 q2 divided by r square. In the second case, I would say F dash will be equal to the force acting between the point charges in that given medium, that will be k divided by the dielectric constant of the medium multiplied with q1 q2 divided by the separation r dash square in the second medium. Now, this is k divided by 5 into q1 q2 divided by r/5 square, because it is mentioned in the question that separation becomes r/5 and the dielectric constant is 5, which would give you F dash is equal to k q1 q2 divided by r square and in the denominator you will have 5 into 1 by 5 square, that is 1 by 5, and that will go up and make it 5k q1 q2 divided by r square, which means f dash is equal to 5 times f. The correct answer would be option C, 5 times f. Alright, we will move on to the next question. It's a very simple, straightforward question there. You just have to take ratios, and it's a very simple ratio-based question. We'll now look at the next question. This question says, the speed of sound in oxygen at STP will be approximately. Now, speed of sound in a given gaseous medium will be V is equal to root gamma RT divided by M. Now, gamma is the adiabatic constant, R is the gas constant, and capital T is the absolute temperature, and M is the molar mass. In this question, gamma is 1.4, that multiplied with R is 8.3, that multiplied with temperature at STP is 273 Kelvin, that divided by molar mass for oxygen would be 32 into 10 raised to minus 3 in SI units, and that would give you approximately 314.85. all right, that much meters per second, because everything is taken in SI units, which is very close to option B, which says 310 meters per second. So option B is the one we will choose here. All right, we will move on to the next question. Again, it's a direct formula based question. The question says, a uniform field of 2 into 10 raised to minus 3 Tesla acts along positive y direction. A rectangular loop of sides 20 centimeters and 10 centimeter with current of 5 ampere is in YZ plane. The current is in anti-clockwise sense with reference to negative x-axis. The magnitude and direction of the torque is. Now, let's draw the axis here. This is x, positive x, this is negative x. This is positive y, this is negative y, and this is positive z, and this is negative z. Now, the coil is in the YZ plane, so I would say that the coil is somehow like this, the YZ plane. The current in it is in anti-clockwise direction from the negative x with reference to the negative x direction, which means from the positive x side it would be in clockwise direction. So this is how the current would be flowing in the coil. Now, if this is true, according to the right hand thumb rule or right hand screw rule, we could say that the magnetic dipole moment of this loop or this coil would be in negative x direction. So this is how your M vector would be. And the question says that the magnetic field is in positive y direction. So this is how B vector would be. Now, to find the torque, please understand the fact that torque vector is equal to M vector cross B vector, which means the direction of torque vector would be the direction of M cross B, and according to right hand screw rule, it would be downstairs or to minus z direction or negative z direction. And now let's look at the magnitude of the torque. The modulus of the torque will be equal to M cross B here, that is basically MB sine 90, because the angle between M and B is 90 degrees here. Now M is NIA, since the number of turns for this loop is only just 1, I would say it is IAB, and that would be 5, that is I, multiplied with the area will be 0.2 into 0.1 in SI units. That multiplied with B would be 2 into 10 raised to minus 3. Now, this would be 0.02 here. 0.02 multiplied with 5 will give you 0.1. 0.1 into 2 is 0.2. 0.2 into 10 raised to minus 3 will be 2 into 10 raised to minus 4. That will be the magnitude, and the direction will be in negative z direction. So the correct option would be option C. Option C is the correct one. 2 into 10 raised to minus 4 Newton meters along negative Z direction, right? That's how we solve it. It's a very simple question. You just have to make sure that you don't miss the directions here as given in the question, right? We'll move to the next one. The next question says, a block of mass 5 kg is placed on a rough inclined surface as shown in the figure. If F1 is the force required to just move the block up the inclined plane and F2 is the force required to just prevent the block from sliding down, then the value of F1 vector minus F2 vector is. Now, we'll solve this problem for a generic case and then substitute the values to give the answer to this specific question. Now, here is the inclined plane. This is the mass. And please understand the fact that the weight will act downwards, and that is mg. The component of weight down the incline would be mg sine theta, and the component of weight perpendicular to the incline would be mg cos theta. And the normal reaction is acting up or perpendicular to the surface upwards, and that is r here. All right, please understand the fact that r matches with mg cos theta, and r is equal to mg cos theta. Now, this is how the forces are, and then the incline is rough, so definitely there is friction. In the first case, we are trying to get the block moving up the incline. So in the first case, definitely the applied force is up the incline, that is F1 is up the incline. You're trying to get it to move up the incline, and the weight, the component of weight down the incline would be definitely mg sine theta. And please understand the fact that when you are trying to get it to move up, when you're just trying to get it to move up, the impending motion is upwards and the friction will be acting down the incline. This will be friction, and friction is equal to mu times r, that is mu mg cos theta. All right, so in that case, for the situation where you are just getting it to move up, considering that to be an equilibrium, you will have F1 is equal to, that is F1 matches both mg sine theta and the friction, that is mg sine theta plus mu mg cos theta. All right, now for the second case, when you are trying to prevent it from falling down, understand the fact that the force that you're applying is still upwards because you're trying to prevent it from falling down. Your force is up the incline, that is F2. The weight is definitely acting down the incline. The component of weight is acting down the incline, that is mg sine theta. And since you're just preventing it from falling down, the impending motion is downwards, and hence the friction will be upwards. And that will again be equal to mu mg cos theta, which means for that equilibrium, when it is just about to move down, F2 and F, that is F2 the applied force and the friction, matches mg sine theta, that is F2 plus mu mg cos theta will match mg sine theta, which means F2 will be equal to mg sine theta minus mu mg cos theta. Now, what we are required to find out is F1 minus F2. This is F1 here, minus F2, you know, will give you 2 times mu mg cos theta, and that is 2 into mu in this question is 0.1, that multiplied with m. Question says that the block has 5 kilogram mass. This is F, this 5 here, and then there is G, that is 10, and then cos theta is cos 30, that is root 3 by 2. 2 gets cancelled out, and then you have 0.1 and 10 would multiply to give you 1, and then the final answer would be 5 root 3. And surprisingly, you don't see that here in the options. So none of these options could be selected. The correct answer would be 5 root 3, and we'll leave it at that. Right? We'll move on to the next question. The next question says, by what percentage will the illumination of the lamp decrease if the current drops by 20%? Now, when the current drops by 20%, the current becomes 80%. That is, I2, the current in the second case, will become 80 divided by 100 of I1, or basically 0.8 times I1 will be what I2 is. Now, the illumination is related to the power, the energy per second that is radiated, that is basically power. So I could connect illumination with power, and power is proportional to I squared, that is P2 by P1 will be equal to I2 divided by I1 squared. Alright, which means P2 is going to be equal to P1 multiplied with I2 is 0.8 I1, so that basically makes it 0.8 squared, which gives you 0.64, that is 0.8 squared is 0.64 times P1, or P2 becomes 64 divided by 100 P1, or P2 becomes 64% of P1. So the percentage decrease, so if P2 becomes 64% of P1 finally, the decrease in percentage decrease will be equal to 36%. The correct answer would then be 36. That is because 100 minus 36 will give you 64. All right, that's how you solve it. Now, the next question says, the mass number of nucleus having radius equal to half of the radius of the nucleus with mass number 192 is. Now, the volume of a nucleus is proportional to the mass number, which actually means volume will be 4 by 3 pi r cube, which means r cube will be proportional to A. In that case, I can say that A2 divided by A1 will be equal to R2 by R1 cube. Now, the question says the second nucleus has half the radius of the first nucleus, which means R2 by R1 cube will become 1 by 2 cube, and that is A2 by A1, or A2 is equal to 1 by 2 cube into A1. The first nucleus has mass number 192, and that multiplied with 1 by 2 cube will be 1 by 8. That will be the mass number of the second nucleus, and that will be equal to 192 by 8 is 24. So A2, mass number of the second nucleus, will be 24. The correct option will be option C, giving 24 as the answer. Right, now, the next question says a gas mixture consists of 8 moles of argon and 6 moles of oxygen at temperature capital T. Neglecting all vibrational modes, the total internal energy of the system is. Now, the total internal energy here will be equal to the sum of the internal energies here of argon and that of oxygen here. Now, that will be equal to number of moles of argon multiplied with CV for this gas, and that multiplied with T. That plus again number of moles of oxygen multiplied with CV and the temperature T here. Now, argon is a monoatomic gas, and I could say that CV for monoatomic gas is what we should use here. So I'll just note that here. And oxygen is a diatomic gas, so CV for oxygen or CV for that particular gas could be that for a diatomic gas. Now, see, number of moles of argon is 8. You have 8 multiplied with CV for a monoatomic gas is 3 by 2 R. That is because it just has 3 degrees of freedom, and that multiplied with T. Plus for oxygen you have 6 moles here. That multiplied with, for a diatomic gas, CV would be 5 by 2 if you're neglecting the vibrational modes. That is given in the question here. 5 by 2 is there because you have 3 degrees of translational freedom and 2 rotational degrees as well. So we have 5 by 2 R here, and then you have T. Now that gives 24 by 2, that is 12 RT, plus you have 30 by 2, 15 RT. That gives you 27 RT. The correct answer would be 27 RT. Option D is the correct answer. That's how you solve it. It's a very simple direct question. You just have to know that these two gases are one of them is monoatomic and the other one is diatomic, and you should choose the corresponding values for CV for both cases. Now, the next question says the mass of the moon is 1 by 144 times the mass of a planet, and its diameter is 1 by 16 times the diameter of a planet. If the escape velocity on the planet is v, the escape velocity on the moon will be. Now, if this here is a planet of mass mp and radius rp, if there is a small mass at the surface of it, the escape velocity could be calculated as the required energy to be given in the form of kinetic energy that would make the total energy 0, or the kinetic energy corresponding to the escape velocity should be equal to the modulus of the negative gravitational potential energy of this body here, which means when the total energy is calculated, you'll get 0 as the answer. So basically, half m v escape square will be equal to gmp m divided by rp. When you cancel off m from both sides, you get ve is equal to root of, that is escape velocity is the root of g, or actually 2 times g, then mp divided by rp. mp is the mass of the planet, rp is the radius of the planet. Now, for the moon here, it is very clearly given that we can say that for moon, this will be equal to 2g mass of the moon divided by radius of the moon here. The question tells you very clearly that mass of the moon is 1 by 144 times mass of the planet. So you have 2g here intact, and then you have mass of the moon becomes mass of the planet divided by 144, and then divided by radius of the moon is radius of the planet divided by, you have 16. The diameter and the radius is just 1 by 16 times for the moon as that of the planet. Now, this would give you root of 2g mp divided by rp multiplied with a root of, when 16 goes up, by 144. And that basically is, this here is VE, already we know that. That is VE multiplied with, you have 4 here as root 16 and then 12 here as root 144. So this is 4 by 12, and that cancels off to VE by 3. The correct answer would then be VE by 3. That is P by 3. Escape velocity for the planet divided by 3 will be the escape velocity for the moon. All right, now we will move on to the next question. The next question here is statement based, and the first statement says electromagnetic waves carry energy as they travel through space, and this energy is equally shared by electric and magnetic fields. Statement 2 says when electromagnetic waves strike a surface, a pressure is exerted on the surface. We have to figure out whether these statements are correct or wrong. Now, the first statement is actually true, and it is one of the most fundamental data that we study in the chapter. Please understand the fact that when you calculate the energy density of the electromagnetic wave, the average energy density of the electromagnetic wave, the average energy density is contributed by 2 components. That is 1, the magnetic field, and the 2 is the electric field. The contribution of average energy density by the magnetic field is exactly equal to the contribution of energy density, the average energy density, by the electric field. That is one of the most important things that you study in the chapter. That's a true statement. For the second statement, please understand the fact that when light is incident on a surface, photons strike the surface and a certain momentum is delivered to the surface by the photons when they are absorbed or reflected. So the per second momentum delivered on the surface will contribute to the force that is acting on the surface due to the radiation, and that divided by the area, that per area will give you the radiation pressure. So that is actually true. Light actually exerts a pressure on a surface when it is incident on it. So option 2 or statement 2 is also correct, which means both statements 1 and 2 are correct. Option B will be the correct option here from the list. We will now go to the next question. It's a theory-based question here. The question says, when unpolarized light is incident at an angle of 60 degrees on a transparent medium from air, the reflected ray is completely polarized. The angle of refraction in the medium is. Now, this question is actually based on Brewster's law, polarization by reflection. If this is the interface between the medium, just understand the fact that from the question we have light incident at a certain angle, certain incident angle of 60 degrees here, and a part of it will get reflected and a part of it will get refracted into the medium. And if the reflected ray, if this is unpolarized light, the incident ray is unpolarized, and if the reflected ray has to be polarized, according to Brewster's law, this happens when the angle between the reflected ray and the refracted ray is exactly 90 degrees. So this is how Brewster's law explains polarization by reflection. Now, this is 60 degrees. This has to be 60 degrees as well. The angle of reflection will be 60 degrees again. Now, this has to be the angle between the reflected ray in air and the refracted ray in the medium has to be 90 degrees. And since this is a straight line, this is a normal, to complete 180 degrees, this angle must be 30 degrees here. So the angle of refraction in the medium will be 30 degrees. It's a very simple, straightforward question from Brewster's law. Right? We will move on to the next question. The next question says, the resistance per centimeter of a meter bridge wire is small r, with X ohm resistance in the left cap. Balancing length from left end is at 40 centimeters with 25 ohm resistance in the right cap. Now, the wire is replaced by another wire of resistance 2R per centimeter, and the new balancing length for the same settings will be at. Now, for the first setting here, we have X in the left gap, 25 in the right gap, and this here is the meter bridge wire, and you get a balancing length at, say, L1 here, and this should be definitely 100 minus L1, but I'll still call it L2 here for convenience. Now, the resistance of this portion will definitely be L1 into resistance per centimeter, that is L1 into R. And this part will have a resistance of L2R. A balanced meter bridge is exactly a balanced Wheatstone bridge as well. So I can say that X by 25 is equal to L1R divided by L2R. And that basically will be equal to L1 by L2. This is actually the resistances here. Alright, for the second setting, we have the same X ohm in the left gap, the same 25 ohm in the right gap. This is the new meter bridge wire, which has 2R resistance per unit length, and I'll get a new balancing length, if at all it is new. That'll be L2 dash, or that's actually L1 dash, and this one will be definitely L2 dash as well. Now the resistance of this portion will be L1 dash into 2R, and this portion will have a resistance that is L2 dash into 2R. Now again, for the balancing condition, I have X by 25 being equal to L1 dash into 2R divided by L2 dash again into 2R. It's very clear that if I cancel these off, I'll get L1 dash by L2 dash is again X by 25. Now, please look at these expressions here. If X by 25 is equal to this and X by 25 is again equal to this ratio here, we can say that L1 by L2 will have to be equal to L1 dash divided by L2 dash, which means the balancing length will not change. So the balancing length for the same settings in the second situation will be again 40 centimeters, because it is 40 centimeters for the first setting. It's a very simple question. Conceptually, you can answer it directly, but I just wanted to simplify it so that you have no confusion left regarding this. We'll now go to the next question. Next question says, the measured value of the length of a simple pendulum is 20 centimeters with 2 millimeter accuracy. The time for 50 oscillations was measured to be 40 seconds with 1 second resolution. From these measurements, the accuracy in measurement of acceleration due to gravity is n percentage. The value of n is. Now, please understand the fact that G, or rather T, the time period of oscillation for a simple pendulum, is equal to 2 pi into root L divided by G. Squaring this would give you T square is equal to 2, or rather 4 pi square into L divided by G, which means G has to be equal to 4 pi square into L divided by T square. Now, maximum permissible error in G, maximum permissible relative error in G, delta G by G would then be equal to delta L divided by L plus 2 times delta T divided by T. Now, that multiplied with 100 will give you the corresponding percentage errors. Now, this is what we need to find out. Delta L by L is the error in measurement of L by the measured value of L, that is 2 millimeters divided by 20 centimeters, that is 2 into 10 raised to minus 3 divided by 20 into 10 raised to minus 2, that multiplied with 100 here, plus 2 multiplied with error in T, that is 1 seconds, divided by the measured value of T, that is 40 seconds, that multiplied with 100. Now we can simplify this, that will give us the answer. This would be basically 2 into 10 raised to minus 1 divided by 20 into 10 raised to minus 2. That is basically, this is actually 2 into 10 raised to minus 1. This is actually 1 here. That plus you have 2 into 10 raised to 2 into 100 by 40 would be 100 by 40 is 2.5. 2 into 2.5 is 5 here. This is basically 1 plus 5, that is actually 6. 6% is the correct answer. We'll go with option A, 6%. All you have to do is make sure that you don't make a mistake here while simplifying this numerical expression. We'll now go to the next question. Next question says, consider two physical quantities A and B related to each other as E is equal to B minus x square by AT, where E, x and T have dimensions of energy, length and time respectively. The dimension of AB is. Now, look at this expression here. B is subtracted with x square, which means that dimension of B will have to be equal to dimension of x square, which is basically L square. So we already have the dimension of B. Now, look at the remaining portion of the expression here. So E must have the dimension that is given by the dimension of what is in the numerator, that is L square, divided by dimension of A into dimension of T. That would mean that A will have a dimension that is equal to L square divided by dimension of E multiplied with dimension of T. That is L square divided by dimension of E is, that is energy, is m L square T raised to minus 2, that multiplied with T here. That gives us 1 by m T raised to minus 1. T into T raised to minus T will be T raised to T into T raised to minus 2 will be T raised to minus 1. That is in the denominator. That would mean you have it as m raised to minus 1 T. That is A. So you need to find the dimension of AB. And AB would give you m raised to minus 1 T multiplied with dimension of B will be L square. So the correct answer will be L square m raised to minus 1 T raised to 1. Option A is the correct one. We'll now go to the next question. It's very simple here. You have to just make sure that you use the principle of homogeneity correctly and solve it without errors. We'll go to the next part, next question. The question says, we have a circuit here and we need to find the suitable truth table for the given circuit. Now, look at this expression here. This here is A and this here is B complement. I'll just write that here, B complement here, and this is A. So what reaches here would be A plus, this is an OR gate here, so A plus B complement is what reaches here. Now, this here is B and this here is A complement, and this is an OR gate again, so what reaches here would be B plus A complement. Now, this is a NOR gate here, which means what would get to Y would be NOR of these two terms, that is B or A plus B complement plus B plus A complement whole complement. That is what Y is. Now, we'll try expanding this Boolean expression. That would be, I'll be using the expression which says P plus Q whole complement will be P complement dot Q complement. That's what we'll be using here. That means this would yield A plus B complement whole complement dot B plus A complement whole complement. All right. Now, this again using the same expression would give you A complement dot B complement complement, that dot, this would give you B complement dot A complement complement. All right. Now, that would give you, this is A complement dot B, then that dot B complement dot A. Now, this is what Y is. If you look at this expression, you can easily identify the corresponding truth table. For this to be 1, both these terms would should give you 1. Now, if this part should give you 1, A should be 0, which means A complement will be 1 and 1 dot 1, and B should be 1 as well at the same time. So at the same time, A should be 0 and B should be 1 for this part to give you 1, which is required for the entire, which is one of the requisites to get this entire expression to give 1. So if that is true, if A is 0 and B is 1, you'll get definitely 1 dot 1 here. But at the same situation, since B is 1, this will be 0 dot 0. That will yield you 0. At the same time, there is no possible way in which you can get 1 for this expression. For any possible, there is never a possible way for this expression to become 1. For all the possible inputs, it's very clear from this expression that if this has to yield 1, both of these terms should give you 1. There is no possible way in which for a given set of values for A and B, both these terms can give 1. It can never happen. Which means for any input, this gate, the answer Y will be 0. So the truth table which tells me that is table A, where Y is 0 for all the set of inputs. It's very clear from this expression. All you have to do is to get to this point and then analyze the possibility for this yielding 1, that is both the terms being 1 simultaneously, which will never happen. It's very clear, right? That's how you solve it. We'll move to the next question now. The next question says, in an AC voltage V is equal to 20 sine 200 pi t is applied to an LCR circuit which drives a current I is equal to 10 sine 200 pi t plus pi by 3. The average power dissipated is, now the average power is Vrms into Irms, this is P average into cos phi. P average. Now, Vrms will be 20 divided by root 2 because 20 is V0 or Vmax. And Irms would be 10 divided by root 2, and cos phi Phi here is the phase difference between voltage and current. Phi here will be pi by 3. It's very clear from these two functions here. The phase difference between voltage and current is pi by 3. So cos phi will be cos pi by 3. So I'll have basically 20 into 10 divided by 2 here, multiplied with cos 60. Pi by 3 is 60. Cos 60 is 1 by 2. That will give me 200 by 4. That is equal to 50 watt. 50 watt is the correct answer. Option B is the correct one here. We will now move on to the next question. The next question says, in a photoelectric effect experiment, a light of frequency 1.5 times the threshold frequency is made to fall on the surface of photosensitive material. Now, the frequency is halved and the intensity is doubled. The number of the photoelectrons emitted will be. Now, initially, the plate has a certain work function phi naught, and that corresponds to certain h nu naught, where nu naught is a threshold frequency. In the first case, the light incident has a frequency, the incident photons, energy per photon will be equal to, say, h nu 1, and nu 1 is 1.5 times the threshold frequency phi naught, which means that energy per photon is greater than phi naught in the first case. That is the first case. In the second case, please understand the fact that the frequency is made half of the first case. Energy per photon is actually, I could say that this is actually h nu 1 is actually h into nu naught into 1.5. All right. Now, that is energy per photon in the first case. In the second case, energy per photon is halved from what it used to be in the first case, which means EP2 will then be equal to 1 by 2 times EP1. That is energy per photon in the first case. That is basically h nu naught into 1.5 divided by 2. That is 0.75 times h nu naught. Now, please look at this case here. You don't have to go any further after this, because for this question, that is 0.75 times h nu naught is definitely less than, this is energy per photon in the second case, that is definitely less than the threshold frequency, that is threshold, or the work function, that is h nu naught, which means no emission takes place. No emission takes place here for the second case, because the energy per photon is less than the work function here. All right. Now, which means irrespective of the intensity, what intensity can do is just increase the number of photons. But as long as the photons do not have the energy that is equal or greater than the work function, there will be no emission. So even if the intensity is increased, you're just increasing the number of photons. That will still not be sufficient. That will still not be sufficient to cause photoelectric emission here. Please understand the fact that is purely because the second radiation here in the second case, after you do the halving of frequency from the first case, you won't have any emission. In the first case, there will definitely be emission. In the second case, there will be no emission at all. So the answer will be 0, because there is no emission at all. It's a very simple question. You need not simplify anything here. You just have to compare the values and make sure that you understand that there is no emission here. Now, we will move to the next question. The next question says, a body of mass 2 kg begins to move under the action of a time-dependent force given by F vector is equal to 60 I cap plus 60 square J cap Newton. The power delivered by the force at the time t is given by. Now, this is force. F is 60 I cap plus 60 square J cap. The acceleration will be basically force vector divided by mass. That will be equal to 60 I cap plus 60 square J cap divided by 2. That is 3t I cap plus 3t square J cap. That is the acceleration vector. Now, velocity vector in that case will be equal to integral a dt from 0 to t. Now, please understand the fact that the body begins to move. There is no initial velocity at all. So, this vector can be directly calculated by doing integral a of t dt from 0 to t. And that is integral 3t I cap plus 3t square j cap dt from 0 to t. And that will give you v vector is equal to 3t square by 2 I cap plus then you have 3t cube by 3 j cap. This is v vector here. That would be rewritten as 3t square by 2 I cap plus t cube j cap. Now, that is what you have for v vector. The power is given by F dot V. Alright, so what we need to do here is to take the dot product of the force, that is 6t I cap plus 6t square j cap, that with velocity vector here, that is 3 by 2 t square I cap plus t cube j cap. That would give you 6t into 3 by 2 t square plus 6t square multiplied with t cube. This is basically 9t cube plus 9t cube plus this is 6t raised to 5. The correct option, that means what would be the answer? The correct option would be 9t cube plus 6t raised to 5. Option A is the correct one. That's how we solve it. The next question would be, I think we can move on to the next question right away because it's a very simple question. You just have to do some math here. That's all it takes. We will go to the next question now. The question says two vectors A vector and B vector having equal magnitudes R are inclined at an angle theta. Then, now, please understand the fact that modulus of A vector is equal to modulus of B vector and that will be equal to R here. And we need to find, we'll start with calculating what is the modulus of A plus B. Modulus of A plus B will be equal to root of A square plus B square plus 2AB cos theta. Now that is basically root of R square plus, again, R square plus 2R square cos theta here. Alright, that is basically 2R square plus 2R square cos theta within the root, and that makes it, if I take 2R square out here, I'll have 2R into root of 1 plus cos theta. 1 plus cos theta would be, this is root 2R here, 1 plus cos theta would be 2 cos square theta by 2. That would give you root 2R multiplied with, again, root 2, and you have cos theta by 2. Alright, that is 2R cos theta by 2. That is the answer. 2R cos theta by 2 will be the answer. The correct option would be modulus of A plus B will be 2R cos theta by 2. Option B is the correct answer here. Alright, it's explained in detail here. We will now move on to the next question. We'll now start with the numerical section of this paper. The first question here says, a body of mass m is projected with a speed u, making an angle of 45 degrees with the ground. The angular momentum of the body about the point of projection at the highest point is expressed as root 2 mu cube divided by xg. The value of x is, now, this here, O, is the point of projection. The particle is projected with the speed u at 45 degrees here. It will definitely follow a parabolic path, and this is the highest point, and we need to find the angular momentum of the particle when it is at this point about the point of projection. Now, at this point, the velocity of this particle v will have a value that is equal to u cos theta, that is u into 1 by root 2, because cos theta is 45 degrees here, that is u by root 2. Now, the momentum, the linear momentum P will be equal to mv, that is mu divided by root 2. Now, the position vector of this particle about the origin, about the point about which we need to calculate the angular momentum, would be this vector here, r vector here, and this is r perpendicular. That is the perpendicular distance between the line or the direction of linear momentum and the point about which you need to find the angular momentum. The magnitude of angular momentum here is calculated as r perpendicular multiplied with the value of p, that is the linear momentum, multiplied with the perpendicular distance between the line of linear momentum and the point about which you're calculating the angular momentum. Now, p we know is mu divided by root 2, but we need to find r perpendicular. It's very clear that r perpendicular is exactly equal to the maximum height of the projectile. So h max is what we have. H max will be equal to u square sine square theta divided by 2g. That is u square sine square 45 divided by 2g. Sine square 45 will be 1 by 2. So you have u square by 4g there in place of r perpendicular. So this will give you mu cube divided by 4 root 2 g. We need to compare this with the expression given. To do that, I'll multiply both the numerator and denominator with root 2. That will give me root 2 times mu cube divided by root 2 into root 2 is 2. 4 into 2 will be 8g here. Now, if you compare these expressions, in place of x, you have 8. So the answer here, the value of x is equal to 8. That is how we solve this. It's a very simple question. These are the first few things that we study when we start understanding about angular momentum. We'll now go to the next question. Next question says, in the following circuit, the battery has an EMF of 2 volt and an internal resistance of 2 by 3 ohms. The power consumption in the entire circuit is. Now, please understand that these two lines here are zero resistance lines. So these 2 points will be shorted and these 2 points will be shorted as well. So I can draw an equivalent figure for this circuit, and that will be 2 ohms on top, and in the middle this arrangement here becomes just like this. And then again this 2 ohm underneath. Finally, we can complete the circuit with the remaining portions. 2 by 3 ohms here, and this is 2 volts. These are all 2 ohms each. Alright, now 2 ohm parallel to 2 ohm will give you 1. Again, 2 ohm parallel to 2 ohm again will give you 1. 1 series with 1 will give you 2. That makes it 2 parallel to 2 parallel to 2. This is what we have. This again is 2 by 3 ohms, and this is 2 volts. Now, 3 identical resistors of 2 ohm in parallel will give you 2 by 3 ohms here, which would make the circuit much more simpler. That will be 2 by 3 ohms here, and again 2 by 3 ohms here, and this is 2 volts. Now, the R equivalent for this circuit would then be 2 by 3 ohms plus 2 by 3 ohms, that is 4 by 3 ohms, and V would be equal to 2 volts. The power is what you're required to find out. Power is V squared by R, that is 2 squared divided by 4 by 3, that is 4 divided by 4 by 3, that would be equal to 3. The answer would be 3 watts. That's how we solve it. It's a very simple question. You just have to find the equivalent resistance of this circuit. We'll move to the next one. Next question says the distance between charges plus q and minus q here is 2L, and that between plus 2q and minus 2q is 4L. That is here. The electrostatic potential at point P at a distance r from the center O is minus alpha QL by r square into 10 raised to 9 volts, where the value of alpha is, you can use the value of K as given here. Now, there are two dipoles here. The first dipole is minus Q to plus Q. The second dipole is minus 2Q to plus 2Q. They are in reverse order. So, I'll just redraw, I'll just draw the figure in a different way so that you can understand how these two dipoles are positioned. This here is the first dipole that I call it P1. P1 will have the value, the dipole moment will have the value of either one charge, that is Q, multiplied with the separation between them, which is 2L. And the point capital P here is right here, marked with the position vector R at a certain angle 60 degrees between the position vector and the dipole moment vector. That is the first dipole. The second dipole, that is a longer one, starting from the minus 2Q to plus 2Q, will have a dipole moment or electric dipole moment which has a magnitude equal to either one charge, that is 2Q, multiplied with the separation between them, that is 2L, or rather that is 4L, that is given in the question. We have 4L here, which is equivalent to 8QL here, and this one would be equal to 2QL. Now, the point P is again positioned with position vector R exactly the same way, because the centers of both these dipoles coincide. This is O here. Now, this angle here, the angle between the position vector and the dipole moment vector, would be 120 degrees. That is very clearly marked here. This is 60, this has to be 120 degrees. Now, the electrostatic potential at point P due to these two dipoles will be given by superposition principle. That will be equal to potential due to the first dipole plus the electrostatic potential due to the second dipole. Now, V1 or electrostatic potential due to a dipole is given by Kp by r square into cos theta. So, we have K P1 divided by r square into cos theta 1 here, plus K P2 divided by r square into cos theta 2 here. Alright, now I'll take K by r square in common. So P1 cos theta 1 is what I have. P1 is 2QL into cos theta 1 is 60 in the first case. So cos 60 is 1 by 2, and that plus P2 cos theta 2 is what we have here. P2 is 8QL. That multiplied with cos theta 2 is cos 120, and that is minus 1 by 2. Now, how will we solve this? We have K is 9 into 10 raised to 9, and that divided by r square will give you, the remaining portion would then be, this is QL minus 4QL. Alright, that gives you minus, I'll just write it later, that's 9 into 10 raised to 9 here, divided by r square multiplied with minus 3QL. That much volt. So this can be rearranged to match this pattern. That will be minus 27, 3 into 9 is 27, and that multiplied with QL divided by r square multiplied with 10 raised to 9 is what it would be. When we compare with this expression, we'll see that in place of alpha, we have 27. So alpha is equal to 27 is the answer to this question. Alpha is equal to 27 is the answer to this question. We will now move on to the next part. Next question. The question says, light from a point source in air falls on a convex curved surface of radius 20 centimeters and refractive index 1.5. If the source is located at 100 centimeters from the convex surface, the image will be formed at. Now we have a convex surface here with a radius of curvature 20 centimeters and the refractive index mu is 1.5. An object is placed here at 100 centimeters from the curved surface, and we need to find the position of the image formed. But the position of the image formed should be found with respect to the object. That's actually a very tricky part here. We will get to that very soon. Now, to find the position of the image for refraction at curved surface, the standard formula would be refractive index of the image medium divided by image distance minus refractive index of the object medium divided by object distance is equal to difference between these refractive indices, that is mu image minus mu object divided by the radius of curvature of the surface. Now, the object medium here is air because that is a medium from which the incident light strikes the interface. So mu object is equal to 1. The object medium has to be air, and mu image will be equal to 1.5 because it's the other medium across the interface, interface that is here. Now, that would give us mu image is 1.5 divided by V. It is unknown, we'll find that from this expression, minus mu object is 1 divided by U. The object distance is minus 100 centimeters because we have to calculate it with respect to this point, and we have to travel in the reverse direction of the incident light to measure that distance. So that is minus 100 here. That is equal to mu IM minus mu OB will be equal to 1.5 minus 1. That divided by radius of curvature is plus 20 centimeters because to measure the radius of curvature from the pole, we travel in the right direction or in the direction of incident light. Now, this is how we solve it. We can rewrite it. It is 1.5 divided by V is equal to, this becomes 1.5 minus 1 is 0.5. 0.5 by 20 will be 1 by 40. And this is plus 1 by 100 here, that when it goes to the other side, it becomes minus 1 by 100. That makes it 1.5 is actually 3 by 2. So I'll just rewrite it as 3 by 2V is equal to, this would become 200 at the base. And here I'll have 5, I'll have 2 here. Makes it 3 by 2V is equal to 3 divided by 200, which means V is equal to 100 centimeters. Now, V is equal to 100 centimeters is the image distance, and that distance is calculated from this point here. So please understand that the image will be formed somewhere here, 100 centimeters from this point here. Now, we need to find the separation between the image and the object, that is the position of the image with respect to the object. Now, this is 100, that is where the image is. This is where the object is. So this separation is 100 plus 100. So the answer would be 200 centimeters here. If you miss this point, your answer will be wrong. So this is how we solve it. That's a very easy expression to solve. But the only problem here is remembering this important point. We'll now move to the next question. The next question says, two identical spheres, each of mass 2 kg and radius 50 centimeters, are fixed at the ends of a light rod so that the separation between the centers is 150 centimeters. Then the moment of inertia of the system about an axis perpendicular to the rod passing through its middle point is x by 20 kilogram meter square, where the value of x is. Now, this here is a rod and it is a light rod, which means we need not consider that when we are calculating the moment of inertia. Now, two spheres are here of mass 2 kilograms. I'll just call it M for now, and radius R. It's a perfectly symmetric setup, which means to calculate the moment of inertia of the system about the axis passing through this midpoint here, all I have to do is to calculate the moment of inertia of this sphere about this axis and multiply that with 2. So the answer would then be 2 times the moment of inertia of the sphere about O. moment of inertia of this axis is actually what I call O here. Now, how do you find IO for this sphere? I know that ICM for this sphere, that is the moment of inertia of this sphere about an axis passing through its own center of mass, will be equal to 2 by 5 mr square. That will be equal to ICM. Now, to find the moment of inertia of this sphere about this axis, we have to shift it using parallel axis theorem by a distance d. Alright? Now, so IO for that single sphere, or I would say I of the sphere about O, will be equal to ICM plus md square, that is 2 by 5 mr square plus m into d square. Right now, the final moment of inertia of the entire system about this axis would be 2 times this value. So I have 2 into ICM plus md square, that becomes 2 by 5 mr square plus md square. Now we'll substitute the values here. 2 stays there, 2 by 5 stays exactly there. Mass of the sphere is 2 kilograms, so I have 2 here. That multiplied by the radius of this sphere is 50 centimeters, that is 0.5 meters or 1 by 2 meters. So I have 1 by 2 squared here, plus m again is 2 kilograms. That multiplied with d here, this entire distance is 150 centimeters. So this has to be 75 centimeters, this distance here. That is 0.75 meters, that is 3 by 4. That is 3 by 4 squared here. Now, that would be 2 into 2 multiplied, 2 into 2 cancels off with 2 square in the denominator. That makes it 1 by 5 on top. And that plus 2 into 9 by 16 will be 2, that is actually 9 by 8. Alright, that's what we should solve. So this actually becomes 2 into, this is 40 multiplied with 8 plus 5 into 9 is 45. So that gives you 2 into, this is 53 by 40. You cancel this off. The answer would be 53 divided by 20. We have to compare the answer with x by 20 kilogram meter square, and x will be equal to, I'll write that down here, x will be equal to 53 is the answer to this question. That's how we solve it. We will now move on to the next question. The calculation is slightly lengthy because I have to explain it in the process. If you do it on your own, it will be much quicker. We'll now move on to the next question. The next question says, 2 circular coils P and Q of 100 turns each have same radius of pi centimeters. The currents in P and Q, it's actually Q here, are 1 ampere and 2 ampere respectively. P and Q are placed with their planes mutually perpendicular with their centers coinciding. The resultant magnetic field induction at the center of the coils is root x millitesla, where x is. Now, this is how the coils will be in mutually perpendicular planes, and this coil will have a certain magnetic field, magnetic induction at the center in this direction. This coil will have a magnetic field in this direction here, and the net magnetic induction would be the resultant of these two. I'll call this B1, I'll call this B2. So what we are required to find out, B is in fact root of B1 square plus B2 square. Now how will we calculate B in this case, or B1 and B2 in this case? B1 will be equal to mu 0 I1 into N divided by 2R. Similarly, B2 will be equal to mu 0 I2 N divided by 2R again. Now, only the currents in these coils vary. Everything else is exactly the same. So if I work it out here, B would then be equal to mu 0 N divided by 2R multiplied with root of I1 square plus I2 square. That's what we'll have here. Now that makes it 4 pi into 10 raised to minus 7 multiplied with 100 divided by 2 into the radius is pi centimeters. It is given in the question, that is pi into 10 raised to minus 2 here. That multiplied with root of I1 is 1 ampere, I2 is 2 ampere, that is 1 square plus 2 square. Let's simplify this now. 2 pi and 4 pi will leave 2 on top. That will be 200 into 10 raised to minus 5 multiplied with root 5 here. That would then become 2 into root 5 multiplied with 10 raised to minus 3, that much Tesla. That in fact can be rewritten as, if I take 2 into the root, that makes it 4 inside, that is root 20 into 10 raised to minus 3, or that is root 20 milli Tesla. So x will be equal to 20 here. X is equal to 20 is the final answer. That's how we solve it. It's a very simple question, and it is a regular type of a question that we always try and solve when we study these sections. We will move on to the next question now. Next question says two blocks of mass 2 kilogram and 4 kilogram are connected by a metal wire going over a smooth pulley as shown in the figure. The radius of wire is 4 into 10 raised to minus 5 meters, and the Young's modulus of the metal is 2 into 10 raised to 11 Newton per meter square. The longitudinal strain developed in the wire is 1 by alpha pi. The value of alpha is, now you know that stress divided by strain is equal to y, which means strain which we need to calculate is equal to stress divided by y, which is basically force, the restoring force per unit area, that is stress, and then that along with y in the denominator. Now please understand the fact that the force acting here, the load acting on the wire, would be the tension acting in it, and that tension for this Atwood machine would be equal to 2 m1 m2 g divided by m1 plus m2. This tension will exactly be the force here, and that will be equal to 2 into m1 is 2 multiplied with m2 is 4, that multiplied with 10 on top, divided by, you have m1 plus m2, that is 2 plus 4. And this actually would be 160 divided by 6 here. 2 plus 4 is 6. This is 4 into 4 is 160 divided by 6, or we could actually make it 80 divided by 3. We'll use that here very soon. Now, area of cross section A can be calculated as pi r square. Pi is here, and then r is 4 into 10 raised to minus 5. That makes it 4 into 10 raised to minus 5 square. And that is basically pi into 16 into 10 raised to minus 10. That is what we have. So let's bring everything here. We'll use tension in the place of force, that is 80 by 3 divided by, we have pi into 16 into 10 raised to minus 10 here, and that is area, and then that multiplied with y is 2 into 10 raised to 11 here underneath. And that would give us 80 divided by, we have 3 multiplied with 2 multiplied with 16, and then that multiplied with pi, and along with that we have 10 underneath. So this cancels out, 0 here, or 10 and 80 cancels off, and leaving 8 on top. And then what we would have is 8 cancels off with 16, and that leaves 2 at the bottom. So what finally I would have is 1 by 12 pi. The answer has to be compared with 1 by alpha pi. It's very clear that alpha is 12. So the correct answer would be alpha is equal to 12. That is how we solve it. The numerical evaluation is what you should be very careful about. So 12 is the answer. Alpha is 12 is the answer. We'll move on to the next one. Next question says, the magnetic flux phi linked with a closed circuit of resistance 8 ohm varies with time in seconds as phi is equal to 5t square minus 36t plus 1. The induced current in the circuit at t is equal to 2 seconds is. Now, we'll first calculate the induced EMF, that is equal to minus d phi by dt, and the function for induced EMF is what we'll have. That is what we'll find out first. That is minus d by dt of this function here, that is 5t square minus 36t plus 1. That would give you minus, this is 10t minus 36 is the induced EMF as a function of time. So at t is equal to 2 seconds, we have induced EMF will be equal to that is at 2 seconds, induced EMF will be equal to minus 20 minus 36, that is minus of minus 16, that is plus 16. Now that is the induced EMF there. We need to find the induced current. Induced current I induced is equal to E induced divided by R, that is 16 divided by the resistance is 8, that is 2 amps. 2 ampere is the correct answer. 2 is the answer to this question. We will now move on to the next question. The next question says, a nucleus has mass number A1 and volume V1. Another nucleus has mass number A2 and volume V2. If the relation between mass numbers is A2 is equal to 4A1, then V2 by V1 is. Now, remember the idea that the volume of the nucleus is proportional to the mass number, which means V2 by V1 will have to be equal to A2 divided by A1, which is very directly, which can very directly be calculated from this. Here A2 by A1 is equal to 4, which will exactly be V2 by V1. So the answer to this expression, to this question, is 4. It's a very simple, very straightforward question, very easy. You can save a lot of time trying to solve this question. Now, the next question says, time period of simple harmonic motion of mass capital M in the given figure is pi into root alpha capital M by 5k, where the value of k alpha is. Now, in this arrangement here, it's actually a spring mass system here, and the time period of oscillation can be calculated by the expression t is equal to 2 pi root m divided by k effective. So all you have to do here is to find the effective spring constant of this combination. Now, we have two springs here of spring constant k in parallel, and that will give you 2k, k plus k will be the effective combination. So that makes it, the string combination would then become, this is k, and I have 2k here as a combination of these, and then I have further another k here. This is what I have. Now, 2k and k are in series, which means the effective of that would then be 2k into k by 2k plus k, that is 2 by 3k. This is 2 by 3k, and this is again k. Now, they are in parallel combination, so that would give you an effective of 2 by 3k plus k, that is basically 5k by 3. 5k by 3. Now, bring that here, that is k effective. So we have t is equal to 2 pi root capital M divided by 5k divided by 3, or that makes it 2 pi into root 3m divided by 5k. Now we have to compare this with this expression here. Remember, there is only pi here outside, so we have got to take 2 inside into the root. That makes it pi here, root 2 will go inside as 4, and 4 into 3 will be 12m divided by 5k. Now, 12 is in place of alpha here, so the correct answer would be 12. Alpha is 12 here. That is how you solve it. It's a very easy, very simple question. You just have to calculate the k effective. Now, we finished the entire paper here. Please make sure that you go through all the solutions in detail and try evaluating it yourself. Thank you for listening.